Hi students, welcome to our YouTube channel again. Today we are going to discuss a very important topic that is related to ALEKS exams, and the topic is solving calorimetry problem. Okay, so first of all, as we know that what is meant by calorimetry? Calorimetry is like the heat that may be evolved or absorbed. Okay, heat may be evolved or absorbed during chemical reaction. Okay, so now we are going to start the questions related to calorimetry. So the first question is, a 58.4 grams of sample of iron which has the specific heat capacity that is 0.449 joule per gram per degree Celsius is put into a calorimeter that contain 200 grams of water. The temperature of the water starts from 18 degrees Celsius. It means that is the initial temperature of the water. When the temperature of the water stops changing, it's 20.4 degrees Celsius. So it means that is the final temperature. The pressure remains constant at 1 atm. Now calculate the initial temperature of iron sample. Be sure your answer is rounded to two significant digits. Okay, so here we have the first one, that is like the mass of iron that is equal to 58.4 grams. Okay, now the second one, the specific heat of iron that is equal to here 0.449. So 0.449 joule per grams per degree Celsius. Okay, now the next one, we have to calculate the initial temperature of iron. So it means here I am going to write the initial temperature with different color. Initial temperature of iron we have to find. So here let's suppose I am going to write T in degree Celsius. Okay, that is a noun. Now the next one, now the information related to water. So here the mass of, let me change the color. Okay, so here the mass of water is equal to, now you can see here, that is 200 grams. So here I am going to write 200 grams. Okay, now the next one, the specific heat capacity of the water. As we know that the specific heat like of water is equal to, that is equal to 4.184. okay, you have to remember for the water, that is 4.184 joule per grams per degree Celsius. Okay, now the next one, change in the temperature like del T, because you can see here the initial temperature of the water and as well as the final temperature of the water is also present. So it means here the change in temperature will equal to 20.3 minus the initial temperature is 20.4. Here is 20.4 minus the initial temperature is 18 degrees Celsius. So that will equal to 18.0 degrees Celsius. Okay, so the change in the temperature that will equal to how much? Let me find it. 20.4 minus 18.0, so it means that will equal to 2.4 degree Celsius. Okay, now the next one, what will be the change in temperature of iron? So the change in temperature of the iron will be equal to, here I am going to write of iron, will equal to, like the initial temperature, let's suppose we already said that is T minus the final temperature here is 20.4. Okay, and that is in degree Celsius. Okay, now the next one, as we know that the heat of the iron, like for example let's suppose Q of iron is equal to the Q of water, because here are the two samples that are present, like we are comparing iron and water here. Okay, so it means that Q of the iron equal to Q of the water, and as we know that what is equal to Q, Q will equal to, as we know that Q is equal to MC del T. Okay, so it means here Q of the iron will equal to, like M, you can write MC or you can write MS. Okay, S is also like related to specific heat. Okay, now let's suppose the Q will equal to M S del T of iron is equal to the next one Q of water, that will equal to M S del T of water. Okay, now you have to put the values. As we know that here the mass of iron, that is equal to how much? 58.4 times the specific heat, that is 0.449, okay, times, and the del T, that is T minus, and the final temperature is 20.4, is equal to, now the mass of the water is 200 gram, 200 times the specific heat, as I already mentioned, that is 4.184 for water, times now the change in temperature. So here we already find it, that temperature, that is 2.4. So I am going to write 2.4 here. Okay, now we need to check, that is T minus 20.4, we can write as this format, is equal to 200 times 4.184 times 2.4 over, like 58.4 and 0.449 will go into the denominator on the other side. So here is 58.4 times 0.449. Okay, so now we have to calculate it. So that is 200 times 4.184 times 2.4, that will equal to 2008.32 over, now the next one, that is 58.4 times 0.449, that will equal to 26.2216. Okay, so that is equal to T minus 20.4. Okay, first of all we need to divide it here. So 2008.32 divided by 26.2216, so that is equal to here 76.59. Okay, so that is equal to T minus 20.4. Okay, so here you can see that is like here on the left side, that is in minus 20, so it means negative 20. It means when we shift it into the other side or right side, that will be into positive. So it means here T is equal to 76.59 plus 20.4. So it means here the initial temperature will equal to 76.59 plus 20.4, that is equal to 96.99. Okay, so that is your like the initial temperature in degree Celsius. Alright, now you have to convert it into two significant figure, and like here that is mentioned, so it means you have to write here is like 96.99, so it means you can write here is 97 times 10 to power, like here here is also like the power is also mentioned, so it means like in scientific notation, so you have to convert it like 9.7 times 10 to power 1. Okay, so that is your answer, like you can see here the whole one. Let me show you like this. Okay, that is your complete solution of this question. Okay students, so that is our first part of this video, in which we solved like in which we find the initial temperature of the metal of like iron. Okay, so in the next video we will solve the other question that is related to like the calculate the specific heat of the other metal, like the specific heat of the brass according to this experiment. Okay, so if you like our video, then please subscribe us and share our channel. Okay, take care and we'll see you in the other video. Okay, goodbye, take care.